Okay, guys, today's lesson is going to be about probability. We're moving into chapter 10, and we want to learn about probability. So let's start with a bunch of vocabulary. All right, we want to start with first what we call an experiment. Right, and if we look carefully at the vocabulary here, an experiment is an investigation or a procedure that has varying results. The possible results of an experiment are called outcomes. A collection of one or more outcomes is an event. The outcomes of a specific event are called favorable outcomes. So there's 4 vocabulary words in that first paragraph, all right? And let's take a look at, how those vocabulary words work together, how those terms work together. For example, randomly selecting a marble from a group of marbles is an experiment, right? So you'd want to imagine that you had a bag full of marbles and you're randomly selecting marbles one at a time from that bag. Each marble in the group is an outcome. Selecting a green marble from the group is an event. So if we look at this example here, right, it looks like we have a bag of about let's see, 1, 2, 3, 4, 5, 6 marbles. And those are your possible outcomes, right? There are 6 possible outcomes. The event would be choosing a green marble, right? So we want to be able to pick a green marble from that bag. How many favorable outcomes are there? Well, because there are 2 green marbles in the bag, there are 2 favorable outcomes, okay, possible. Right, we have 1 green marble here, 1 green marble here. So that first green marble would be a favorable outcome. That other green marble would be a favorable outcome. So we have a total of 2 favorable outcomes there. Okay. Over here to the left, it says when an experiment is performed at random or randomly, all of the possible outcomes are equally likely. Okay. Now our 5th vocabulary word for this lesson. The probability of an event is a number that measures the likelihood that the event will occur. Probabilities are between 0, right, which means something is impossible, and 1, which means something is certain, including 0 and 1. The diagram relates likelihoods above the diagram and probabilities below the diagram, right? So what we just mentioned there is we have a likelihood, right, would be impossible. Probability would be 0. If we have something that is equally likely to happen or not to happen, right, its probability would be 1/2 or 50%. If we have something that is, or a likelihood that is certain, right, that probability is going to be equivalent to 1. All right? Okay, let's take a look at some questions here. All right. First question says, there's an 80% chance of thunderstorms tomorrow. Describe the likelihood of that event. Well, likelihood, if we look at our table up here, or the terms up here above, on the top of our line, we know that 80% likely, right, or an 80% chance is above 75%, right? So that would be likely to happen, right? Since the probability of 1/2 is 50%, okay? And let's see, right? So an 80% chance would be likely. Right? If we look at these 2 questions here, question 1, the probability that you land on a jump on a snowboard is 1/2, right? Describe the likelihood. Well, if I go up here and describe the likelihood, 1/2, right, it would be equally likely to happen or to not happen. So it would be equally likely that you land a jump as to not land the jump if the probability is 1/2. Question 2, there's a 100% chance that the temperature will be less than 120 degrees Fahrenheit tomorrow. Well, if I look up here, right, a 100% chance, which means it will be certain that the temperature tomorrow will be less than 120 degrees. Okay? Now, key idea next, we want to be able to find the probability of an event. When all possible outcomes are equally likely, the probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. The probability of an event is written as P parentheses event. The probability of an event is equal to the number of favorable outcomes over the number of possible outcomes. Okay, let's take a look at some examples here. Okay, it says you roll a number cube. What's the probability of rolling an odd number? Well, because there are, well, first we would write it this way. Probability of odd, right? And that's going to be equal to, well, the number of possible outcomes, there are 6 possible outcomes on a 6-sided number cube. How many of those outcomes would be favorable? Well, if we're looking for an odd number, you'd have, right, 1, 3, and 5 would be your favorable outcomes. So you'd have 3 favorable outcomes over 6 possible outcomes. So the probability of rolling an odd number would be 1/2 or 50%. Okay, let's look at our next example. The probability that you randomly draw a short straw from a group of 40 straws is 3/20. Well, how many short straws are there? Well, if the probability is 3/20 from a group of 40 straws, we simply want to make a proportion showing that these two ratios are equivalent. So we want to know 3/20 is the same as how many out of 40? We cross multiply and divide, right? So we'd wind up with 20 times n is 20n, right? 3 times 40 is 120, right? And we would divide both sides by 20, and we wind up with n is equal to 6, right? So there'd be 6 short straws, right? Out of 40. Out of 40. Okay? Let's see what we have down here. Some example problems. Scroll up. Okay, in example 2, what's the probability of rolling a number greater than 2? Okay, so we want the probability of, let's see, a number greater than 2. Let's think about that for a second. Well, there are still 6 possible outcomes on that number cube, but how many of those outcomes are greater than 2, right? You'd have 3, 4, 5, and 6 would be the outcomes that are greater than 2. So you have 4 possible outcomes out of the 6 total outcomes that are greater than 2. So that would give you a probability of 2/3, or as a percent, that would be 66 and 2/3% for problem number 3. Let's try problem 4. In example 2, what's the probability of rolling a 7? Well, we would write that as the probability of 7 would be equal to what? Well, there's still 6 possible outcomes on the number cube. How many of those outcomes are a 7? Well, that would be 0, right? There are no 7s on the 6-sided number cube. So probability of 0 out of 6 is going to be 0% for problem number 4. Let's try question 5. Question 5 says the probability that you randomly draw a short straw from a group of 75 straws is 1 out of 15. How many short straws, or how many straws, right, are short? Well, let's think about that for a second, right? How many of those straws are short? Well, if the probability is 1 out of 15, right, and we know that there are a group of 75 straws, we want to know how many of them are short. You could cross multiply or divide, or you could see that 15 times 5 is 5. So if we're using equivalent ratios, we would know that 5, right, n would have to be equal to 5. So there should be 5 short straws, right, out of 75. Out of 75 there. All right, let's go to our next page. It says to find the probability of rolling a 2, a 3, or a 4 on the 6-sided number cube. So we're looking for the probability of 2, 3, or 4. Well, once again, we know there are 6 possible outcomes, and favorable outcomes would be a 2, a 3, or a 4. So there are 3 favorable outcomes out of the 6 possible outcomes. So we have a probability of 3/6 or 50% for problem number 2. All right, let's come down here and look at our spinner. Scroll that up a bit. It says the spinner at the right is spun once. Find the probability of each event. Write each answer as a fraction, a percent, and a decimal. Okay, start with problem B. Problem B is asking for the probability of F, right? Well, here's our F, right here. That's our F. Well, how many F's are there on the board, right? I look around, I only see the one F. So the probability of F, there's only one favorable outcome. Well, how many possible outcomes are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 possible outcomes. So we have one favorable outcome, which is the spinning of an F. We have 10 possible outcomes. So the probability is 1 out of 10. And 1 out of 10 we would write as 10%. Right? They want us to write it as a fraction, a percent, and as a decimal. As a decimal, 10% is, right, 1/10. Let's look at problem C. The probability of a D or a G. The probability of D or G. Let's see what that's going to look like. Probability of D or G. Well, how many D's are there? Well, there's one D. There's one G. So there are 2 possible outcomes out of the 10. Right? Or I'm sorry, we have 2 favorable outcomes out of the 10. Well, if I have 2 favorable outcomes out of the 10 possible outcomes, 2 out of 10 simplifies to 1/5 as a fraction. And we all know 1/5 is 20%. And we know 20% is going to be equal to 2/10 as a decimal. All right. And then let's look at problem D. Problem D asks for the probability of a vowel. Well, how many vowels are there? Well, A is a vowel. I know I'm a math teacher, but I know what vowels are. Let's see. E is a vowel. And I believe I is a vowel. So we have 3 favorable outcomes out of the 10 possible outcomes. So the probability of spinning a vowel would be 3 out of 10. If we write 3 out of 10 as a percent, that's going to be 30%. And if we write 30% as a decimal, 30% would be 3/10 as a decimal. All right? Not too hard. Probability is pretty simple. Right? Should make sense. All right, let's look at another vocabulary word. I think this is term number 6 for the lesson. Right? We want to find probabilities of complements. Well, complementary events are 2 events in which either one or the other must happen, but they cannot happen at the same time. For example, a coin can either land on heads or not land on heads. The sum of the probability of an event and its complement is 1, or 100%. All right. Let's take a look at a problem. We want to find the probability of not rolling a 6. So we want the complement of rolling a 6. The probability of not rolling a 6. Well, the probability of not 6, well, how many not 6s are there? Well, 1 is not a 6. A 2 is not a 6. A 3 is not a 6. A 4 is not a 6. And a 5 is not a 6. So there are 5 favorable outcomes out of the 6 possible outcomes. So the probability of not 6 would be 5 out of 6. 5 out of 6 we know is 83 and a third percent. Okay? Try another one down here. A bag contains 5 blue, 8 red, and 7 green marbles. A marble is selected at random. Find the probability the marble is not red. So we want the probability of not red. That's what we're looking for. Well, how many possible outcomes are there? All right. Well, possible outcomes would be, let's see, 5 plus 8 is 13 plus 7. So there are 20 possible outcomes. How many favorable outcomes would there be? Well, a favorable outcome would be not red. So blue is not red. Green is not red. So we add the 5 blue and the 7 green. That gives us a total of 12 favorable outcomes. So the probability of not red is 12 over 20. And 12 over 20 would simplify to what? What's that, 610? Or 60% would be the probability of not red. Okay? Let's continue with some more examples here. Mr. Harada surveyed his class and discovered that 30% of his students have blue eyes. Identify the complement of this event, then find its probability. Well, the complement of having blue eyes is not having blue eyes. The sum of the probabilities is 100%. So the probability of not blue would be equal to, well, let's think for a second. Well, if 30% had blue eyes, that would lead 70%, right, which would be not blue, right? 70% is 70 out of 100, right? So if 30% of his students had blue eyes, the difference between 30% and 100% would be 70%. So the probability of not blue would be 70%. All right? Let's move on to our next page. Okay. Let's see. The probability of landing in a certain section on a spinner can be found by considering the size of the angle formed by that section. On the spinner shown, the angle formed by the yellow section is 1/4 of the angle of the, or 1/4, yes, of the angle formed by the entire circle. So the probability of yellow would be 1/4, or 25 hundredths, or 25%. Problem A asks us to determine the probability of green and orange for the spinner. Write the probabilities as fractions, decimals, and percents. All right. Let's start with the probability of green. The probability of green is going to be equal to, let's see. Well, when we look at the green, right, here's our green section, right here. This is our green. Well, we know that 1/2 is 50%. We know that half of a half is 25%. So the green looks like it's 1/2 of 1/4. Well, what is 1/2 of 1/4? Probability of green is going to be 1/8. And 1/8 we know is 0.125. because I've made you memorize it all year. And we know that that's 12.5%. We're also asked for the probability of orange. All right, let's do the probability of orange. Let me grab orange here. All right, so the probability of orange. Well, the probability of orange, we can see very clearly, right? Here's our orange, right? This part here, it's going to be 1/2 of the circle. We know that 1/2 is 5/10 or 50%. Okay? Part B asks us to determine the probability of not yellow. The probability of not yellow, even though I'm using the color yellow here, right? What's the probability of not yellow? Well, let's think about that for a second. Well, here's the yellow section here, right? That's 1/4. Well, what's the complement of 1/4? Well, the complement of 1/4, right, would be 3/4. So the probability of not yellow would be 3/4, which is 75 hundredths or 75%. Okay? Continue down here with problem number 10. A bag contains 6 red, 4 blue, and 8 green marbles. How many marbles of each color should be added so that the total number of marbles is 27, but the probability of randomly selecting one marble of each color remains unchanged? Well, let's take a look and see what we have here. We have 6 red, 4 blue, 8 green. So that's a total, use black here, right? That's a total of, 18 marbles. So we have a total of 18 marbles. We know red is 6. So red is 6 out of the 18 marbles. We know blue is 4 out of the 18 marbles. And we know green is, I'm trying to use green here. Right, green is 8 out of the 18 marbles. Okay, that's what we know. We want to know how many marbles of each color should be added so that the total number of marbles is 27, but the probability of randomly selecting one marble of each color remains unchanged. Well, we've got to make some equivalent fractions here, guys. All right, so it would start something like this. We want the total number of marbles to be 27. So we know 18 plus 9, that's going to give us 27. Well, how many red out of 9 is the same as 6 out of 18? Well, 18 divided by 2 is 9, so 6 divided by 2 is 3. So 3 marbles out of 9 is the same as 16 out of, is the same as 6 out of 18. We want to know how many out of the 9 marbles that must be added to get a total of 17, how many of those 9 marbles must be red? We want to do the same for blue. How many out of 9 is the same as 4 out of 18? Well, half of 18 is 9, so half of 4 is 2. So 2 out of the 9 marbles that we add to the 18 have to be blue. We want to do the same thing with our green marbles. How many out of 9 must be green? Well, 8 out of 18 is the same as 4 out of 9. Well, we have our answer now. We'd have to add 3 red marbles. We'd have to add 2 blue marbles. And we'd have to add 4 green marbles, right? Because we're asked how many marbles of each color should be added, right? So that the total is 27, but the probabilities don't change. By adding a total of 9 marbles, we get to 27 from 18, and we've kept our probabilities the same because we've used equivalent fractions. All right? Well, that's the end of the lesson here. I hope that that's been helpful, and we'll see you soon.